Hello, hello, hello. Okay, so this is the Chapter 3 review sheet for Honors Geometry. It is the review sheet for the test coming up. So I was going to talk about it and try to get the right answers. Okay, so if they're wrong, let me know. So the first problem says if triangle PQM is congruent to triangle DEF, then PM equals DE, and that is false, because PM is right here and DE is right here. If we look at the order of things, it's not true. We could draw the triangles, but look at the order of the letters. It's false. Number two, equiangular triangle has 3 congruent sides. That is true. Because if the base angles are congruent, the sides are congruent. And if these angles are congruent, these two sides are congruent. So each angle is 60 degrees, which makes all the sides the same. A right triangle has 2 right angles. That is false. If that was the case, then you'd have 2 right angles here and some other angles here, but you can't have a triangle. So, number 4, if you were trying to prove ABC and DEF, so the best way to do that is to draw them. So I would put like ABC here, DEF. And A is congruent to D, so this angle and this angle. C is congruent to F, so C and F. What sides would you need congruent? Okay, by angle, side, angle. So it's AC congruent to DF. By angle, side, angle. Angle, side, angle. If a triangle is isosceles, then it has at least 2 congruent sides. Now, it could have 3. Remember, all isosceles triangles are not necessarily equilateral triangles, but all equilateral triangles are isosceles triangles. If AB is congruent to BC and angle C is equal to angle B, what type of triangle is it? Well, this is equilateral. It's an interesting problem because I will show you in the drawing. Equilateral triangle. You could say equiangular, but it's the same. So this one triangle here is ABC, and AB is congruent to BC, so AB is congruent to BC. And angle C is congruent to angle B. Now, if you rotate this triangle, these two would be the base angles, and these two would be the legs. So they're all equal. Everything's equal. So it kind of goes around the triangle to get everything equal. It's an equilateral triangle. So that was a good problem. Number 7, is this triangle isosceles, scalene, or equilateral? Well, the only fact that we have is that the 3 angles equal 180. So what I have to do is take this expression, and this expression, add them together to get 180. So 2x and 1x is 3x, and 2 more x is 5x. So 5x, which is those 3 x's, 9 minus 4 is 5, so plus 5 equals 180. So that tells me that x, all right, or 5x equals 175. So x is equal to 5 goes into 175 times 17 times. All right? So 17 times is 17 is equal to x. Now, what we do for x then is substitute it in here, here, and here. Now, 3 times 17 is 52. Oh, no, 3 times 17 is 51. 4 times 17 minus 1 is, what do I have for the answer key here? I got to look. X is 17, x is 35. Oops, x isn't 17. 35, I was thinking 17, that's what I get. So x is 35, I made a mistake there. And 3 times 35 is 105. And 2 times 35 plus 4 was, 2 times 35 plus 4 is 74. And 4 times 35 minus 1 is 139. Since all three sides are different, then it's a scalene triangle. So we get x equals 35, which I don't know why I was thinking 17, but x is 35, and substituting it back in for x tells us that all three sides are different, and that is a scalene triangle. Problem number 8, the triangle has a perimeter of 32, and then again we want to see if it's scalene, isosceles, or equilateral. So we add the three expressions together and equal it to 32. So let's see, we have these two, 2x and 1x is 3x, and 7 minus 3 is 4, plus 10 is 14, and that's equal to 32. And if I subtract the 14, I get 3x is 18. That's great. And then x is equal to 6. Substituting the x back in here is 13 for this side. 2 times 6 is 12, minus 3 is 9 for this side, and then 10 for this side. So all three sides are different, so that is a scalene triangle. Okay? The next problem is another problem where we have to use algebra. So we have to show it's scalene. There's a lot of scalene going on here. We have to show this problem is scalene. So we do x plus 3 is AB. 3x plus 2 is AC. And 2x plus 3 is BC. So we know that the perimeter is 20. So 2x plus 3x is 5x, plus another x is 6x. 2 plus 3 is 5, plus 3 is 8. 6x plus 8 equals 20. We subtract the 8 and we get x equals 2. Subtract the 8 and divide by 6. Okay, so this side is 2 plus 3, which is 5. This side is 3 times 2 plus 2, which is 8. And this side is x 2 times 2, which is 4, plus 3, which is 7. So we can see that all three sides are not equal. It's a scalene triangle, just like the previous two problems. All right, so number 10 is another problem where we are using algebra to find the lengths of these two segments. So problem 10 says AT is 2x plus 7, so I'm going to write it right there, 2x plus 7. And then RT is 3x minus 4. TD is 2x plus 2. We have this AT is a median, right? So here's AT, it's a median. And we look at these two segments that are congruent in this problem because medians created these two congruent. Medians create congruent segments, and so this median creates two congruent segments here and here. So 3x minus 4 is equal to 2x plus 2. We're going to solve for x and substitute to find the answer. Subtract the 2x and I get x, add the 4 and I get 6. So x is 6 in this problem. We're going to substitute 6 in, so 3 times 6 is 18, minus 4 is 14. Now this is also 14, because they're both congruent. 2 times 6 is 12, plus 7 is 19. So RD is from here to here, which is 28. and AT is this segment, which is 19. Number 11 says triangle CAR is isosceles with base CR. So we know that this angle, the base angle, is congruent to this base angle, and we know if it's isosceles that this side is congruent to this side. So here's the algebra. X squared, here's the equation from the facts. X squared plus 2x equals negative 5x plus 44. So I'm going to add the 5x and subtract the 44 and set this equal to 0. That's how we solve quadratics. X squared plus 7x minus 44 equals 0 is what I get. Now I have to factor this. So I get x minus 4, I guess, and then x plus 11, because 11 times 4 is negative 44. 11 times negative 4 is negative 44, and 11 minus 4 is 7. So we now can say that x equals 4 or x equals negative 11. Now we have to, in this problem, you see we have a negative sign right here, and if we multiply the negative 5 times the negative 11, we're going to get a positive number. So 11 just might work in this problem, because when we plug it in, we're going to get a positive value. So if we want to find the length of AC here, that's our task, it's going to be the same as the length of AR. Now, if it were me, I just substitute it into AR. So I'm going to substitute the 4 in, and I get negative 20 plus 44. So I get negative 5 times 4 plus 44. That's 20. 24, not 20. Right, that's 24. And this should also be 24. So 4 squared plus 2 times 4, that's 16 plus 8, which is also 24. Now, if I plug in negative 11, let's see what happens. So negative 11 squared plus 2 times negative 11 is 121 plus negative 22, which is 99. Okay? Now, do we get the same thing? Negative 5 times negative 11 is 55 plus 44. Yep, it's 99. So, to find the length of AC, it's two answers. It's 24 or 99. So that's a tough one, but not impossible. Okay, so this is part 1, no proofs. And the next video will be part 2, and we'll be taking a look at 1 proof, 2 proof, and 3 proofs. Okay, so the first part of the test is no proofs. It's all algebra. We've got to look at that, see how to get these done. This is a video to help you, and I hope it did. And if you didn't watch it and didn't do it and did it on your own, you're good, man, and you understand it. So I have to check that. I want to check the answer key real quick on this last one. Let's see. Did I do this one right? 11. Did I do it right twice? So let's see. 11 is 99 or 24. Yeah. Okay, so you're good to go with that. Have a good day, and the second part of this review will be the proofs.